Hey everyone, today we will be focusing on graphs today, particularly focusing on recursive breadth-first search for a directed graph, and without any further hesitation, let's get started.
And now we're going to perform breadth-first search recursively. So similar to what we have done already for depth-first search, we're going to have two functions. We're going to have our helper function, and then we are going to have our actual function we will call in the main function. So similar to what we did before up here, except for what we're going to be doing is that we're going to call this void. Yeah, I'll just put right here, void breadth-first search recursive. And since breadth-first search uses q, we use q integers and q, and then we'll have a vector of a Boolean vector indicating what has been visited. And then if the q is empty, we're just going to return as a base case indicating, hey, there's nothing in the queue, and we're going to indicate for our first vertex to be at the front since queues operate by first in, first out. Then we're going to pop the queue to be able to output our vectors, vertices as well, and for each vector accordingly, similar to what we have done there. Indicate a space. We're going to have a for auto loop for auto I is equal to adjacency vector at the start. Notice, like we did over here for a vector inside of our depth-first search recursion for each iterator. We're going to have begin, and then while the iterator is not at the end, we're going to increment our iterator accordingly, and if the iterator has not visited a vertex inside of our adjacency list, we're going to have visited, I'm just going to call this right here just to avoid misspelling, I indicated as true, and then we're going to push each iterator accordingly, and then we will perform breadth-first search recursive. This is where the definition of recursion actually comes in, and then indicated what has been visited as before. So we are putting in the same parameters as we have already done thus far, and then we will put in our actual function that's going to call upon the helper function and just go through accordingly. Breadth-first search recursive start int v for vector Boolean vector indicating what has been visited with our vertex that we have initialized at the top over here. And indicated as false, saying we have not visited, and then q, integer of q, visited each vertex for true, and then we're going to push each vertex accordingly inside of our queue, and then we will do, sorry about that, breadth-first search recursive, there we go, indicate for q, and then visited as well, and count and l. So we're calling upon this function that we have for our helper function, and then yeah, so that's recursive breadth-first search right here. Now we're just going to do what we did before, recursive depth-first search, and then recursive breadth-first search recursive, and all we got to do, we're calling upon this function at the start, similar to how we named it before for depth-first search start. We're going to go over here, perform breadth-first search, and we are going to give this similar output. It's just the way of how we designed it. All right, the build has succeeded. Let's go to the top, and yes, it has actually performed the following breadth-first search and depth-first search accordingly, giving the similar output. It's just a nature between how we are actually building out breadth-first search and depth-first search iteratively and then recursively as well. And so yes, this was our direct graph and how we actually perform breadth-first search recursively, and this is the full context for our directed graph on outputting each part whenever we have the following tasks. And now we will head over and focus on our undirected And then we will focus on our undirected graph for our next iteration as well. So yeah, let's just move forward.
Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.